So students, in this video I'm going to explain you from exercise 1C question number 7. The question here is like this: say, find the HCF and LCM. You have to find the HCF and LCM of the following positive integers by applying the prime factorization method. That means you have to apply the prime factorization method and to find the HCF and LCM of these given positive integers. Now, if you look very carefully in question number 1 and in all the questions of this question number 7, in all the sub questions, they've given you 3 integers each. That means what? They've given you 3 positive integers. Okay. Well, you know that I've already taught you in previous videos and previous questions how to find HCF and LCM when they have given you 2 positive integers. And all the other questions that you have done in previous videos and previous sums, we have learned how to find HCF and LCM when they give you just 2 positive integers, but this time they've given you 3 positive integers. Okay, so let us see how to find HCF and LCM when they give you more than 2, that is more than 2 positive integers. It can be 3, it can be 4. So in this case it's 3 positive integers. Okay, so here we start. So first of all, we'll find the prime factorization of 24, 36 and 176 in the same manner that you have learned for other numbers. Okay, for other sums. So first of all, we begin with the prime factorization of 24, and since you know that we have to, when you do prime factorization, we start from 2, and to be able to divide by the prime number 2, the given number should be an even number. And for even number, remember, you have to look at the units place digit. Okay, units place digit. If the unit place digit happens to be 0, 2, 4, 6 and 8, they are even number. So that's why, because of this unit digit 4, 24 is even. Because of this unit digit 6, 36 is even. And because of this unit digit 6, 176 is also even. So all these numbers are even. So means all these numbers we can prime factorization by 2 in the beginning. Okay, so let's start with 24. So we'll divide by 2 because it's an even number. So 2 ones are 2, 2 means 0, only 4, 2 twos are 4. 12, as you know that 12 is a multiple of 2 and moreover it's even number. 2 6 are 12, 6 is multiple of 2, so 2 3s are 6. 3 is an odd number, moreover 3 is a prime number, and 3 prime number, see 3 is a prime number, so 3 we divide by itself. 3 ones are 3, so means we have finished the prime factorization of 24. Okay, now let us do in the same way the prime factorization of 36. So 6 even numbers, so we can divide by 2. Okay, the first prime number 2. 2 ones are 2 because 2 twos are 4 big, so 2 ones are 2. 3 minus 2, 1. That 1 goes and join with 6, and from the left is 1 and 6, 16. 16, so table of 2, 2 8s are 16. So 18, you know 8 is even number, 18 is a multiple of 2, so 2 9s are 18. 9 is odd number, moreover this is a multiple of 3, so 3 3s are 9, and 3 is a prime number, so 3 1s are 3. Okay, we cannot divide to 9, so we divide by 3. Okay, so here we'll do for 176. 6 even numbers, so we'll divide by 2. If I take only one smaller than 2, so I should take 2 numbers, so 17. So if you keep on telling table of 2, recalling table of 2, then you'll find that 2 8s are 16. 2 8 times 16, and 2 9s 18 back, so means 2 8s are 16. So from 17 when we subtract 16, we get 1. That 1 goes and join again with 6, again it's 16. So 1 and 6 16, so 2 8s are 16. If you look this 88, it is even number, so because of this even number we can again divide by prime number 2. Okay, so 2 4s are 8, here means a 0, no carry, and 2 4s are 8. 4 44, 44 is also even because of this 4 unit digit 4, so we can divide by 2. So 2 2s are 4, 2 2s are 4. Again 2 is even number, so 2 1s are 2 and 2 1s are 2. So see, we have got 11. Now 11 is odd number, we cannot divide by 2. Moreover, 11 is a prime number. You can see here the list of prime number, so 11 is a prime number. So all prime number, while prime factorization, you divide by itself. Okay, so 11 ones are 11. So we finished all the 3 prime factorization. Now we will try to find the HCF and LCM. Okay, we'll see how to find. So first of all, we'll write here prime factorization of 24. So let's try the prime factorization 24. So 24 we got 2 into 2 into 2 into 3, and this we write in power notation. So here the prime factors are 2 and 3. So we write 2 once, but 2 coming 3 times, so we write power 3, 2 cube. That is 2, 2, 2, 2 cube. And 3 is a prime factor, and since coming only one time, so power 1. Okay, so we've written the prime factorization of 24. Now we'll write the prime factorization of 36. For 36 we got 2 into 2 into 3 into 3. When we write in power notation, 2 is a prime factor and 2 coming 2 times, 2 square. 3 into 3 means 3 square, because 3 is a prime factor and it's coming 2 times. Okay, so it means 2 square into 3 square is the prime factorization of 36. Now we'll write the prime factorization of 176. So we got 2 into 2 into 2 into 2 into 11. So 2 is a prime factor, write once, and 2 coming 4 times, write power 4. 11 is a prime factor coming 1 time, power 1. Okay, so after having done all the 3 prime factorization of the given 3 numbers, then now we can find the HCF. So basically it's better to start with HCF. Okay, finding all this. Therefore HCF of 24, 36 and 176 is equal to, let me tell you once again, what is HCF? HCF is the product of all the common prime factor. Common, it should be present in all three. Common. This time there are 3 numbers given, so that prime factor should be present in all 3. Okay, only in 1, only in 2 is not enough. Okay, it should be present in all 3 numbers. Okay, that factor should be a common prime factor of all the three given numbers. Okay, or all the given numbers. So means HCF is a product of all the common prime factor with the lowest power. Let's see which are the common prime factors here. Which are the common prime factors? See, in 24 we have prime factor 2. In 36 also we have prime factor 2. In 126 also we have prime factor 2. Yes, so 2 is common to all 3. 2 is a common prime factor. Okay, so we write 2. After writing 2, since 2 is common, so write 2 once, but in this 2 you put the lowest power. When you find HCF, you give the smallest power. So see, among all the prime factors 2, which is the smallest power? If you look very carefully, in the first 24 we have 2 has power 3. In the prime factor 36 we have 2 has power square. In the prime factor 176 we have 2 power 4. It means 3, 2 and 4, and the smallest is 2, that is square. So 2 square is the lowest power of 2. Okay, square is the lowest power of 2. Okay, here among all these 3. Okay, now let's see the another prime factor we have or not. Let's see 3. 3 is a prime factor. So 3 is a prime factor of 24. 3 is there. 3 is present in 36 also. See, 3 is a prime factor of 36 also. 3. But if you look in 176, 3 is not a prime factor of 176. Therefore we conclude that 3 is common in 2 given numbers, but it's not present in 176. Therefore 3 is not a common prime factor for all 3. Okay, all the 3 given numbers. Okay, that's why we do not write, because numbers are 3, so it should be present in all 3. Okay, so here we conclude that 3 is not a common prime factor. Okay, because it's not present in 176. Okay, so that's why we will not write 3. What about 11 also? Say 11 is a prime factor for 176, but 11 is not a prime factor for 24 and 36. That means 11 is not present here, so 11 also will not write. So now you can see that 2 is the only common prime factor and square is the lowest power. So now 2 square, 2 into 2, 2 into 2, 4. So means we have got the answer. Okay, so the HCF of these 3 numbers, the highest common factor of these 3 numbers is 4. Okay, so we have found HCF. Now we'll find LCM. Therefore LCM of 24, 36 and 176. Now when you find LCM, let me repeat once again how to find LCM. LCM is nothing but it is the product of all the prime factor, all the prime numbers that you see here, right? All, it is the product of all the prime factor with the highest power, with the biggest power. So first write all the prime factor. You can see that 2 is a prime factor here, 3 is also a prime factor. Write all the prime factor first, and 11 is a prime factor. There's no other prime number. 2, 3 and 11. So in these 3 prime factors you'll find 2 and 3 and 11. Okay, so prime factors are done. Now write in all these prime factors their highest power. See, in the prime factor 2, the highest power is power 4. That means, right, we'll write 2 raised to power 4 is the highest power for this prime factor 2. For 3, there are two prime factors coming for 3, and the highest power is what? Here 1 and here 2. The 2 is bigger, so 2 is the highest power. Okay, 2 square. And 11 is only one time. 11 is power 1, so we have to give this 1 only. Okay, now we'll from power notation we'll write in normal form. Okay, so 2 raised to power 4 means 2 4 times multiply, so 2 multiply 4 times. It's not 2 into 4 8. Okay, it means that 2 into 2 into 2 into 4 times. So 2 2s are 4, 4 2s are 8, 8 2s are 16. That means what? If you multiply 2 4 times, 2 into 2 into 2 into 2, you'll get 16 into 3 square. 3 square means 3 into 3 2 times. So 3 into 3, 9. 3 3 is a 9. And 11 power means 11 only one time. Okay, so now we'll multiply and we'll write the answer. Okay, now we'll multiply and we'll write the answer. So let us multiply then this one. See, I multiply 16 and 9. 9 6 54, carry 5, 9 1 9, 9 plus 5 14, and multiply by 11. It will be 144 144 1584. So it comes 1584. So this is the required LCM of the given numbers. Okay, so means we have found the HCF and we have found the LCM. Okay, HCF is 44. HCF is 4, and LCM is 1584. So I hope you've understood the sum. So same way we can do the other sums from this exercise. Okay, but let me quickly remind you, review. Let's review once again this one. See, recap. Look, first we do the prime factorization of all the three numbers, then write the prime factorization of these three numbers with the powers notation. Then for HCF we write only the common prime factor with the lowest power, and for LCM we write all the prime factor with the highest power, and when we multiply we get the answer. Okay, so thank you. The other question I'll show you in the next video. Thank you.